We were born in a world where the darkness is the only thing we temporarily can see. We cried and cried until the day we learned how to open our eyes. Light. It became the border to separate the day from the night. This is what we see when we are in our darkest time while hoping that everything is gonna be alright. Good day everyone. I am part of Group 5 and today we are going to talk about the properties of light and light phenomena. A topic which we often see every day, but we understand a little about. Light comes from different colors, but collectively, it is white. Nothing is comparable to its speed. Did you know that light is also the joy of our sight? Some of these are what we often do, by being amazed how we look in the mirror or how nature brings colors to our eyes. Some of the natural sources of light are the sun, moon, and lightning. Furthermore, the artificial sources of light are the candle flame, torch, lamp, and other light fixtures. Have you ever wondered why some people who wear eyeglass or contact lens suddenly improve their vision? It is because the refraction of light is currently working. The lenses are made of plastic which bends the light in specific ways. Just like the eyeglass, its bifocals use a convex lens to bend light and make things look bigger. When we happen to see our faces in the pool or any other kind of water, it is called the reflection. However, when you throw a rock in a river, the reflection will be disrupted due to the form waves that the rock created. Moreover, dispersion happens when light passes through a prism. One of the examples is the diamond. When light passes through it, it will split into different colors. All of the things I have said are just the background and some types of light. My other group mates will be the next one to add other information about our topic.
Many scholars have attempted to answer the question what is light throughout history. Optics, being one of the oldest disciplines, has had a big influence over many different fields, and great scholars between many different fields presented here have developed the study of light while leading other fields and intimately associated with the advancement of industry and culture. Before we start with the different new information, discoveries, and inventions, we have to first introduce the most notable names that have etched their names in the history of optics. We have provided 7 prominent people in the study of optics in order ranging from the 4th century BC to the 20th century. First off, a very well-known philosopher from Greece who lived during the 4th century BC. Aristotle is a world-famous Greek philosopher and scientist who contributed to the development of light. He instilled an early understanding of optics, reflection, diffusion, and vision. He felt that light was a disturbance in the air akin to one of the 4 components that comprised matter. The second discoverer is Ibn al-Haytham, a scholar from the 10th century. Haytham was an active scholar in Basra and Cairo, and he is considered by many as one of the most prominent scientists, and some even say that he is the first true scientist. He is a mathematician, astronomer, physician, and philosopher from the country of Iraq. He studied Grecian academics, and he wrote a book called the Book of Optics, which contained observations and experiments on how light works, and this explains how light reflects and refracts through the use of lenses and mirrors. The third discoverer, Christian Huygens, an astronomer from Netherlands that lived at the same century with Isaac Newton. Aside from being an astronomer, he is also a mathematician and a physicist. He made several discoveries to astronomy, including discovering Saturn's rings and the greatest nebula of Orion with a self-built telescope. He produced a study that backed up his theory that light is a wave or wavefront. Huygens, Huygens' hypothesis that light is a wave finally became the accepted scientific position after he argued against Newton's light particle.
Sir Isaac Newton. Sir Isaac Newton was a famous figure in the 17th and 18th centuries. He did a lot of amazing work and studies including optical research into the spectral decomposition of light. He made significant contribution to optics by studying and improving lenses, prisms, mirrors, telescopes, microscopes, and optics. And rather than the pure white as stated by Aristotle, he announced his new study, New Theory on Light and Color in 1672, which argues that light is a mixture of various colors having different refractivity. He also wrote a book called Optics that discusses his light particle theory. Next is Thomas Young. He is a physicist, classical scholar, and archaeologist from England. He made numerous accomplishments in his specialty, including interpreting an ancient Egyptian text and many others. In 1807, he conducted an experiment that demonstrated that interference fringes may be seen from a distance when light from a point light source is shown through two pinholes. He also argued that lights are wave-like in nature, moving and behaving like waves. James Clerk Maxwell is a Scottish theoretical physicist. In 1864, he developed the science of classical electrodynamics, which provided the foundation for modern electromagnetism. Based on the renowned Maxwell equations, he hypothetically predicted the presence of electromagnetic waves. He also proposed that electromagnetic waves travel at the same speed as light and that they are horizontal as waves. Next is Albert Einstein. Einstein was a German-born theoretical physicist who is recognized as the greatest physicist of the 20th century due to his three groundbreaking research and works. These three studies contain work on the photoelectric effect theory, which states that light is made up of protons. The theory of relativity is Einstein's most renowned work. His work on theoretically revealing the photoelectric effect based on the light quantum hypothesis earned him the Nobel Prize in Physics in 1921. And to summarize, many scientists have contributed to the evolution and development of light. But one thing is certain, without them, our technology would not have advanced to this point in our lives, and we would not be able to utilize the use of light.
Thank you for that informative presentation. Before proceeding to the next segment, let's have a quick trivia first. Are you familiar with The Last Supper by Leonardo da Vinci? I bet you are. But did you know that Da Vinci applied immense knowledge of the nature of light, reflections, and shadows in this masterpiece? The Last Supper represents Leonardo da Vinci's captivation in the fields of optics and lights. Dedicated to the truth of lighting in art, Da Vinci examined the reflection of the sunlight on the planet and the moon. After thorough investigation, he found out that the source and the angle of light along the arrangement of characters define the gradient of lightness and darkness. Da Vinci then carried this conclusion in his art. As we can see in the painting, the place most luminous reflects more rays as it is closer to the light, while the illumination of the shadow fades into darkness as the subject becomes farther. Hence, with this work, Leonardo da Vinci became one of the first masters of still art since he pioneered the use of light and optical theory in art. That's all for our trivia. Miss Maranan will now take the lead.
Hello everyone! In this part, we're going to tackle the discoveries and experiments based on the topic we are presenting. But before we delve into that, I have a question for you. What do you get when you add up a bunch of donuts? I will give you 3 seconds to think of your answer. 3, 2, 1. According to optical physicists, it is a croissant. And you know what? That is the result of new research revealing a never before seen property of light called self-torque. This property was discovered by Kevin Dorney and the Captain Ring group through their experiments involving firing 2 lasers at a cloud of argon gas. Doing so forced the beams to overlap, and they joined and were emitted as a single beam from the other side of the argon cloud. The result was a type of vortex beam. The researchers then wondered what would happen if the lasers had different orbital angular momentum and if they were slightly out of sync. This resulted in a beam that looked like a corkscrew with a gradually changing twist. So, what uses does light with self-torque have? Nowadays, it is being used to make ultra-powerful microscopes, move tiny parts of industrial machinery, and send extremely high data rate signals through optical communication networks. Perhaps that's why discovering another new property of light has made other researchers in this field giddy. For the next discovery, a cartwheeling light reveals a new optical phenomenon. Rice University graduate student Lauren McCarthy led an effort that discovered details about a novel type of polarized light-matter interaction with light that literally turns end over end as it propagates from a source. Together with the other researchers of the said university, their findings could help study molecules like those in light harvesting antennas anticipated to have a unique sensitivity to the phenomenon. In the picture, a model by Rice University scientists shows how 2 positively charged spheres attached to springs are attracted to the electric field of light. Due to the motion of the spheres, the spring system scatters light at different energies when irradiated with clockwise and anti-clockwise trochoidal waves. Furthermore, what is the impact of this discovery on society? Since matter can distinguish between these 2 directions, trochoidal dichroism could be used to develop novel spectroscopic tools. Also, freely propagating circularly polarized light interactions can be a key to several technologies, including 3D glasses made of materials that discriminate between opposite light polarization.